Hello everyone, welcome back to Stasis Classes. My name is Kavi Siddiqui and today I am going to teach you one of the most important topic of class 11, chapter number 2, motion in a straight line. That is derivation of equation of motion by calculus method. We generally have three equation of motion. That is first v is equals to u plus 2 u plus at. Second, s is equals to ut plus half at square. Third, v square is equals to u square plus 2as. But they are in uniform motion. Now if we have to calculate all the three equations, we must know that these equation will be calculated by the non-uniform motion equation. That is, first one is a is equals to dv by dt, second is v is equals to dx by dt, and third a is equals to v dv by dx. So without wasting time, first of all, how will you calculate all this thing by calculus? And what is the calculus method? In calculus method, we use differentiation or integration. Now, what is an integration? How will you calculate? Integration is a form in mathematics in which what we do, if we have to calculate the larger properties, the larger thing, what we do, we took the smaller one and we add all the smaller properties and we get the whole property. Like if we have done in calculating the mean thing. If you want to calculate mean, what we do? We add all the components and we get the total component in the mean. Like the mean only we do integration. Now, not going into detail, let me tell you the hints for the doing integration. If you have equation y is equals to x power n and you have to integrate this, and we use the definite integration. In definite integration, we have these limits and you have to put these limits. Okay, so if you want to do differentiation of x power n, then that will be equal to x power n plus 1 divided by n plus 1. What will you do? You increase the power by 1, whatever the power is, you increase the power by 1 and you divide the with that power only. So here, what is needed? What most is needed? First, let me tell you very clearly, if nothing is there, if there is no variable, then it is 1 there. And for constant, if there is a constant, 1, 2, 3, 4, 5 is the number, if there is a constant, the integration is nothing but that variable itself. If you are doing integration with dx, then x will come. If you are doing the integration with dt, then dt will come. If you are doing the integration with v, then v will come. Okay, so here which property we will getting? First of all, let me tell you very clearly that if you have two variable and both the variable are different, one is acceleration and the other is dx, so you have to make sure that you understood that a is constant for dx because they are different physical quantities. So now we'll start with the first equation of motion. For starting the first equation of motion, we have a is equals to dv by dt. For doing this, you have to take this dt to a and integrate both the sides. We integrate both the sides. Here a is equals to dt is equals to dv, and the integration is of dt, so a will come out of the integration, and we do integration from 0 to t dt, and here we have initial velocity u and final velocity is v. Nothing is inside the integration, that is it is 1. So that variable which is integrating will come, that is t, from limit 0 to t, and here also v will come after integration u and v, and we will put the limit. How we put the limit? Upper limit in the place of t, lower limit in the place of t, upper limit in the place of v, lower limit in the place of v, and now we have got our first equation, that is at is equals to v minus u, or v is equals to u plus at. Now I take second equation. What is the second equation in the non-uniform equation? V is equals to dx upon dt. We will move dt to v and we will write v as v is equals to u plus at. So here we will convert v as v is equals to u plus at dt dx. We will multiply dt in the bracket, integration from This is for time, so 0 to t. Here for t, 0 to t, and here for x, 0 to x, 0, so s. Because the physical quantity is not same and of different type, then we will move u out and we'll do integration. Nothing will left inside, so integration will be t. We'll move a as well, and here because t is present, then t power 2 divided by 2 will be there, 0 to t, and here x will be there, 0 to s. We'll put the limits, upper limit in place of t, lower limit in place of t. A by 2 will calculate outside, t in place of t and minus in place of t, and s in place of x, 0 in place of x. From that you will get ut plus half at square is equals to s, and this is our second equation of motion. Not wasting time much, third equation of motion. And for third equation of motion, we have special non-uniform motion equation, that is a is equals to v dv upon dx. v dv upon dx. We will move dx to a, and here what we'll do, we'll do integration from 0 to s, from u to v. We'll take a out because the physical quantities are different, and we do integration, and for integration of dx, that is x, because nothing is present inside the integration, and here the integration will be equal to v square by 2 because the power is 1, and if we increase the power 1 and divide by the power, then v square by 2 will be there. Then you will do the limits. We'll put the limit, first limit, the upper limit s minus 0, and here we'll take the 1 by 2 outside, then v square minus u square. We'll move 2 towards the left side, and this will be equal to 2as is equals to v square minus u square. And this is our third equation of motion. I hope you understand the video, or you understand the topic, which is very important. You must do this topic to get good marks. Thank you so much for watching. Keep watching us, keep commenting, and keep sharing our video. Thank you so much.